Good evening, everyone. So my name is Dr. Suman Sen. So I will discuss about this experiment between a mixture of two bases and hydrochloric acid, right? So you can consider this one as a pre-lab discussion. That means if you have a laboratory experiment after a couple of days, we can discuss this couple of days before the lab. So it would be easy and helpful for the students to be prepared at least theoretically for this experiment, right? So what is the experiment that we are going to do in lab? That would be the estimation of a mixture of sodium carbonate and sodium bicarbonate using hydrochloric acid, right? So in short, we have some unknown. What is the unknown? That is the mixture of two bases. We want to estimate the individual amount of both the bases by titrating that mixture against some acid, right? You can use H2SO4 as well, but here we are choosing hydrochloric acid, right? All right. So as most of us have done some kind of acid-base titrations in their high school days, so what you generally do in acid-base titration, we have some unknown bases maybe or unknown base solution. We titrate that using some unknown acid solution, right? That means the concentration of the acid solution is known, concentration of the base solution is unknown, right? We simply use some indicator in the unknown base solution and we titrate that one using some acid, right? That's a normal way to do some kind of acid-base titration, right? Now I have mentioned that the base solution is unknown, right? The acid solution also can be the unknown solution. In that case, the base solution would be the known one, right? It can be vice versa. It's a very simple way to do it, right? Now, how this experiment is different compared to those easy, straightforward acid-base titration, right? So I would not say this is a difficult experiment, but there's a small trick that we have to play in this case, right? Now the problem is that here obviously we also have one unknown solution, right? But there are two different components of bases in that unknown base solutions, right? And using the known acid, somehow we have to understand in which concentration those two different bases are present in that mixture, right? So what is the trick that we are going to use? It's nothing but just to understand the proper stoichiometric reactions of those two bases individually with HCl. Now what do you mean by this? By this I mean that first you have to understand what is the reaction that is happening when you are adding HCl to sodium carbonate. What is the complete reaction, and then what is the complete reaction of sodium bicarbonate with HCl, right? Now if we So I'm just skipping one slide. I'll come back to the third one. So if we have a look at the reactions of those two bases individually with the acid HCl, right? So the first part here, we can see that sodium bicarbonate is actually reacting in sodium carbonate is actually reacting in two steps, right? The first step, the sodium carbonate is reacting with HCl, giving some salt. In our case, it is sodium chloride, and it is giving sodium bicarbonate. I repeat here, right? So the sodium carbonate that is already in the solution is generating sodium bicarbonate, right? Now remember, we already have some sodium bicarbonate that is already there from the beginning, right? Now whatever sodium carbonate we have, that is actually getting converted into sodium bicarbonate in the first step of the reaction, right? And this transformation, that means the transformation from sodium carbonate to sodium bicarbonate, this one we can monitor by phenolphthalein, right? So this would be the first step of our experiment, where we are going to monitor the transformation of sodium carbonate to sodium bicarbonate using phenolphthalein as an indicator, right? So what is the color change at the end point? I mean, most of us know this, right? In the acid medium, phenolphthalein would be obviously colorless, and as soon as we get to the neutralization point, the color would change to pink, right? The first step is done and dusted, right? Now think about the solution, right? What we have now, we already had some sodium bicarbonate, and now we have some sodium bicarbonate that is coming from the sodium carbonate. And now that would be our last step of the experiment. What is that? Or the titration step, I should say. I should not say last step of the experiment, the titration step. Right? So in this titration step, or the second titration step, what we are going to do, we are going to add some other indicator, right? That is methyl orange. Why we are going to use two different indicators with the two different steps? I'm going to get into that in a bit. But in the second step, we are going to use the methyl orange indicator, right? And we are going to monitor this change of sodium bicarbonate titration. That means the reaction between sodium bicarbonate. So this is the reaction, sodium bicarbonate reacting with HCl, giving us again sodium chloride, water and carbon dioxide, right? So in the second step, the complete titration of sodium bicarbonate is happening, and in that sodium bicarbonate there are two contributions. One is from the sodium bicarbonate that was present from the beginning, and the sodium bicarbonate that is coming from the first step of the titration of sodium carbonate. Alright. So as I said, we are going to use two different indicators, right? And this is a very, very important part of this experiment, right? We have to choose the indicators very, very methodically, right? Or correctly, I should say, in this case. Now, why I'm saying so? Now, the two steps in this titration are having a definite pH range, right? And as we all know that these indicators that we use in these acid-base titrations are nothing but very weak acids or bases themselves, right? And they can act, or they can show their color change only in a definite pH range, right? Now, in the first step of this titration, right, we're using phenolphthalein indicator because the sodium bicarbonate to sodium carbonate to sodium bicarbonate transition that happens in that pH range, right? In that pH range of 8.3 to 10.0, right? And that is why we're using this phenolphthalein indicator, right? And as soon as we're getting the sodium bicarbonate, it is changing to, or it is giving the complete titration, we have to use methyl orange indicator. Why? Because now the pH range has been quite down, quite low, right, compared to the previous step, and that is why we're using phenolphthalein, rather methyl orange indicator for this step, right? What is the color change? Again, I would mention, so in the acid medium, the methyl orange indicator would show reddish orange color, right? And as soon as we get to the end point or the nucleation point, the color would change to pale yellow, right? So that is why you have to be very careful when we are choosing our indicator, right? Now, if I summarize this short discussion as the pre-lab, so what are the steps that we are going to have in this experiment? 5 steps, right? So what is the first step? In the first step, we are going to make the mixture, right? You don't need to prepare the sodium carbonate solution, neither the sodium bicarbonate solution, because they're unknown, right? Because they're unknown, so they will be provided. What is your job? In the first step, your job is to take those two in 1:1 ratio, right? So you can take 20 ml of sodium carbonate and 20 ml of sodium bicarbonate, put it in a Arden-Meyer flask, right? 250 ml or 100 ml flask you can use. I would rather prefer 250 ml flask, right? Because using the same solution, you have to do 2 steps of titration, right? So now you have done with the step 1. You have the mixture of the base in your flask, and you are going to drop couple of small drops of phenolphthalein indicator, right? What is the next step? Obviously, you're going to set up your burette, right, using HCl, and you're going to start the titration. It is the first step, this one, right? So titrating this one using phenolphthalein, right? The sodium bicarbonate is getting converted to, this is a small error from my side. So the sodium carbonate is getting converted to sodium bicarbonate. The color changes of phenolphthalein indicator from colorless to pink, right? Done and dusted, the first step. The second step, using the exact same solution in that same flask, we're adding methyl orange, right? And we're getting the second step of titration, right? We're adding HCl at the end point it's completely titrated. That is the sodium bicarbonate is completely titrated, right? Color changes to pale yellow, right? From reddish orange to pale yellow, and we are done with the titration part. Then we are already done with this 4 experiment or the 4 parts of the experiment, right? The last part would be calculation, and that we can discuss in the next short video, right? I hope until here everything is clear to us, right? If you have some questions, we can discuss in the next short class that we are going to have. All right? Okay, then take care until the next class. Bye bye.